Okay. Welcome everyone. We're going to go ahead and get started. So thank you so much for being here. My name is Kevin Markham. I'll be your instructor for this tutorial. This is Data Science Best Practices with Pandas. Very happy to be here. It's my privilege to be teaching you today. So before I talk about the tutorial, I'm just going to tell you some setup instructions if you haven't done them yet so that you can get caught up with that, and then I'll introduce myself and what we're doing, and then we'll get started. So you'll want to go to the GitHub repository, and I snagged that sweet bit.ly link /PyCon 2019 if you want to go directly there. And there's some instructions here on downloading a CSV file, checking that pandas and matplotlib are working, and that's about it. And there's a link here to the TED Talks dataset. You're welcome to pull that up. We'll use it just a tiny bit. Yeah, go ahead and open your Python environment, whatever environment you're most comfortable with, and put that CSV file into the same directory or wherever you usually open files from. And that's that. If people run into problems, I've got two backups. Backup solutions. One backup is I have some flash drives with the data file on them and some flash drives with Anaconda installers if your machine just isn't working and you want to install Anaconda right now. The other backup is that if at any time you are having problems with your machine, just go to the top of the repo, click Launch Binder, and you'll be running Jupyter Notebook in the cloud with the data file and with the libraries you already need installed. Takes a couple minutes to open, but it's a great solution if you're having big problems with your machine. Okay. All right. So while anyone's getting set up that's not already, I'll just tell you about myself. I live in Asheville, North Carolina, with my wife and my son, and I used to live in Washington, D.C. I'm the founder of Data School. I teach data science in Python, mostly online. I used to teach in person at General Assembly in DC. I have a lot of YouTube videos. Anyone seen one of my YouTube videos on something? Cool. Awesome. Thanks. Cool. Well, I have taught a couple tutorials. I taught a machine learning one at PyCon 2016 and one on pandas at 2018. That was a lot of fun. And since I'm online only, it's a real pleasure for me to be in the classroom these days. So this is great. What we're going to be doing today is my goal is to help you become more fluent at using pandas to answer your own data science questions. So I do expect you know some pandas. That we're going to be doing a lot of exercises. Basically, we're going to have this single data set. I'm going to ask you a question or give you a task. You're going to try to answer it using pandas. And then we'll discuss the answer together. We'll spend a good amount of time on that, where I'll kind of walk through a solution. We can talk about it. And at the end of each section, there are just some takeaways, some best practices that I'm trying to communicate. In terms of the pacing, this is intermediate level, so if you feel beginner to pandas, it might go a little fast. If you feel like pretty advanced, it might go a little slow. But I'm aiming for that middle ground. If you do finish an exercise early, I've in most cases got a bonus written down that I can give you. So always let me know if you want a bonus exercise to work on, if you're just sitting there, and I'm happy to give you something. Alternatively, just help your neighbor, or just explore the data set on your own, make up a question and start trying to answer it with pandas, and I can help you. Yeah, please. Yeah, I might. Oh, please. Okay. So the question is about using a Conda environment for running the Jupyter Notebook. So if you're in a Conda environment and you have installed the notebook in that environment, you'll have access to it. That sounds good. Yep. Let's see, what else? If you are struggling to keep up at any point, don't worry so much about that. Most of the exercises are independent of one another, so you won't get too far behind. Don't worry about the red and green pieces of paper. Final thoughts, if you're not used to using the Jupyter Notebook, that's what I'm going to be using, but you should use what you're most comfortable with. Questions are welcome at any time, but I've kind of timed this out, and it's a lot of material, so if questions are too far off topic, I'll probably just save it for a break or to talk with you one-on-one, and I'm happy to help. We will break from 3 o'clock to 3:20, and we will end at 4:40. All the code I'm typing will be posted on GitHub, so you don't feel like you have to type everything if you're trying to like keep up. But that's it. Any questions for now before I jump into the first exercise? Awesome. All right. So what I'm going to do, so this is all live coding, and I am, this first exercise, we're just kind of going to do it together. So I would encourage you just to type along with me, and we're just going to do an introduction to the data set. And this is really just kind of a warm-up. But go ahead and follow along. In terms of, so this is a data set of TED Talks. Has anyone ever seen a TED Talk? Yes, everyone. Can someone just define quickly what a TED Talk is? A talk about technology, entertainment, or design, or that was the original idea. They're short talks, very popular. They've been around for a long time, and they have kind of a message they're trying to communicate. This data set, actually, before I start typing, there's this page on the Kaggle Datasets website, which, by the way, is a great way to find and explore data sets. And this is a description of the TED Talks data set. If you don't have this open, it might be useful. The thing that may be useful is there's some metadata here about the data set that might be useful for you to understand. So I would keep that page open. But this was scraped from the TED.com website. That's where this came from. And yeah, so I just wanted to kind of set the context for the data set. But let's go ahead and just import pandas. And sorry, it's harder to type and talk than it seems. So I'm using, I think, 0.24, 0.2, but you can use any modern version, should be just fine for today. And we're just going to import matplotlib lib.pyplot as PLT. And if you're in the notebook as well, matplotlib inline. So inline. If you're not in the notebook, that's largely or completely irrelevant. And then we're just going to read in the data set, and we're just going to read it into a data frame called TED. And it's in my local directory, so I'm just going to read right from TED.csv. And let's just take a quick look at the data set. And if you're falling behind, definitely feel free to ask your neighbor if you missed a line of code. Is it okay if I take the font size down 1 notch because I want to get a little more on screen? Is this okay? Or is that a little small in terms of reading the code up here? Bigger? Pretty small? Okay, I'll go back up. All right, all right. All right, so each row in this data set represents a single TED Talk. And we're just going to check the shape, just the shape attribute. So there are 2,550 talks, so those are rows and columns. And then we'll just take a quick look at the D types. This is just what I do when I get a new data set and want to be vaguely familiar with what's in it. We'll just take a quick look at the D types. It's just a blend of integer columns and object columns. Now, object columns are usually strings, but what else can an object column contain? Just go ahead and raise your hand and I'll grab someone. Yeah. For categories, it'll actually say category, I believe. There's something else. So what else can an object type contain? So other than strings, other things, yep. Yeah, so object data types, though they usually have strings, they can contain arbitrary Python objects such as lists or dictionaries. So that is something useful to keep in mind, that they're not always strings. But yeah, the most important thing, we have a bunch of int columns and object columns. And I'm just going to write this and not explain it, and then show you the result. And can anyone tell me what this code is checking for. Right there? Right, so what I did is .isNA.sum. So I'm checking for missing values. That's another useful thing to know when you open up a data set. So isNA, which is same as isNull, isNA outputs a data frame of Boolean values. And then when you sum it, sum sums along the 0 axis, the rows axis, which gives you column sums, and true values are treated as ones, false values are treated as zeros. So a lot happening in that line. But anyway, the bottom line is that speaker occupation has 6 missing values. I'm not going to take any action at this time, but this is something you should know about any data set you're working with. And there's lots of different ways you might deal with missing values, especially if you have a lot of them. But we have very few, so there's not much to say. This isn't really like a big best practice, but the documentation has been migrating over to using isNA and not NA rather than isNull and not null for consistency with drop NA and fill NA. So that's why I've switched to isNA. And you might, I don't know if they'll eventually deprecate the isNull and whatnot, but that's what I'm doing here. So anyway, that's just a brief intro to this data set. We're going to jump into the first exercise, which is going to be very short. But anyone have any questions up till now? Okay. So I'm going to call this, sorry. So this exercise is the following question. Which talks provoke the most online discussion? Okay. So that, you don't have to type that. You can if you want. But that's the exercise. You're going to have to decide which column or columns are relevant to answering this question. Some of the columns are self-explanatory, but you can check out the Kaggle website for descriptions. I will give you about 3 minutes on this. So that's just because it's not that deep of an exercise. But if you've already got an answer, maybe think a little bit beyond the surface as to what I'm trying to get at. But I'll be walking around during every exercise, and you can ask questions. But go ahead and take 3 minutes and try to figure out which talks provoke the most online discussion. All right, that has been 3 minutes. Some of you might have been like, boy, what am I going to do for those 3 minutes? And others are like, I can barely get started. Okay, so I'm going to go through this one. And again, I recognize some folks will find some of this super easy and others will find it super challenging. But which talks provoke the most online discussion? So the first thing you might think to do is to focus on the number of comments, the dot comments or the comments column. So these are the number of first level comments. So the thing I would do is I would use the sort values data frame method and just pass it comments. And then we're going to look at the tail because this is sorting in ascending order, so you'd want the ones with the most comments. So that would be one idea, okay? There are different ways to do it. And you might just conclude, okay, I've decided that since this talk about militant atheism had the most comments in the data set, that this talk provoked the most online discussion. If I concluded that, what would be a possible problem with that conclusion or that approach? Subcomments is one limitation, right? So like nested comments, we're completely ignoring those because we don't have the data. But what would be another possible problem? Right. We don't. There's a lot of data we do want, but we don't have, and that's an example. How about there? Right, how long it's been online, right? Because that's really relevant. Some of these talks have been online for 20 years, others have been online for a day, and so it's relevant how long it's been online. Now, the way I was thinking to correct for this bias is to normalize it by, anyone want to guess? Views is what I'm thinking. So if someone watches a talk, the number of views, if someone watches a talk and they do comment or they don't comment, that would seem to indicate how provocative, if you will, a talk is. So I'm going to create a new column called comments per view, and it's going to be ted.comments divided by ted.views, okay? And I'm creating a new column. I always use dot notation when I can, which I'm using on the right side. You have to use bracket notation when you're creating a new series in a data frame. Thus, that's why I use bracket notation. I put underscores in my column names because I like to use dot notation, so you need underscores there. So I do that, and then let's go ahead and sort by comments per view instead. Use comments per view, and we'll look at the tail again. So now we actually, so that Richard Dawkins talk is still up high, but now we have a different talk we're defining as the most. Sorry, I'll scroll over all the way to the right because when you add new columns to a data frame, they end up all the way on the right. And here's the comments per view column. And all the way at the bottom, we've got our number. This is the greatest number in the data frame. So this talk, called The Case for Same-Sex Marriage, is a different way you might define which talks provoke the most online discussion. So we would interpret this number as for every view of this talk, there are 0.002 comments. Okay? So that's the greatest number, though that number is a little bit tricky to kind of put into real world context. How might I make this more interpretable than what I've got? How might I make this the same information but slightly more interpretable? Views per comment, that is a great idea. That is exactly what I was thinking, is we can just reverse the calculation, invert the calculation, and I'm going to change this to views per comment, and views per comment, and then it'll be ted.views. Maybe the copy paste wasn't the best idea. Ted.comments. Sorry, I should have just typed it. That was silly. All right, views per comment. All right, looks good. And then we'll do ted.sort values, views per comment, views per comment. And then this time we'll look at the head because we want the lowest number, right? It's the opposite. So now I will just scroll over all the way over here. And views per comment, it says 450, which means that it takes 450 views to generate a comment, or 1 out of every 450 people who watches the talk comments on it, which to me is a lot more, which is a lot easier to interpret than comments per view with that small decimal number. So the bottom line for this exercise is this is how I would probably measure with the data we have which talks provoke the most online discussion, but it would be great to have other data. All right, I'm going to show you, just show you on screen a couple lessons I took away from this, but any questions about this exercise before I do that? Yeah, please. Okay. Right. Oh, okay. So you, yeah, no, that's fine. So she basically filtered out a lot of the columns that were irrelevant to the question before doing kind of a similar process. So yeah, you can always the problem with kind of like subdata frames is if you create them and then you do any manipulations to it, you haven't affected the one you created in the original one, so it can be easy to lose track. But sometimes it is nice to create a smaller data frame that focuses on the columns you're interested in. Okay, so I'll just show you the lessons. The lessons I was trying to get across from this exercise. And these are lessons or best practices. Some of these will be data science lessons. Some of them will be pandas lessons. But number one, consider the limitations and biases of your data when analyzing it. So the limitation, as someone mentioned over here, is we only have the first level comments, whereas actually having those nested comments might actually be even more useful for which talks are most provocative because people are saying things and then other people are replying to them. But we can't really correct for that without gathering the data ourselves. And then the bias that we tried to correct for was that older talks have had a lot more time to accumulate comments. So we tried to correct for this by normalizing by views. So that was the first lesson I was trying to get across. The second lesson is just to make your results understandable regardless of your audience, regardless of whether it's just for yourself. And that's why we used views per comment rather than comments per view. So those are just a couple lessons. Hope you found that to be useful. I'm going to move on to the next exercise unless there are any final questions about this one. Okay. All right. So the next exercise is visualize the distribution of comments. Okay. And we're going to talk about this one for just a few minutes before I let you loose on this one. Let's just make a plot real quick with pandas. So we're going to do ted.comments.plot. All right, and here's what we get. What kind of plot is this? A line plot, that is correct. So what do the axes represent? What does the x represent and what does the y represent? X is the index, and what does the y represent? The value of the comments field, right. So it's basically plotted out 2,550 points and connected them by a line. That's what a line plot is. Line plot is not what you would use here because a line plot is for measuring something over time. So if there's not a time component to it, in what you're showing, a line plot is usually not the right choice. I just wanted you to know how to plot using pandas if you haven't done it before. We can learn some things from this plot. We can see that many talks have a low number of comments, and a small number of talks have lots of comments, but that's about it. So this is not the plot I want you to create, But you might know, and in Jupyter Notebook, you put your cursor in the parentheses and Shift Tab, and I'm going to do it 4 times to pull up the signature, essentially the doc string in a lower pane, and you'll see, and it'll be different depending upon which editor you use, but you'll see that there's this kind argument. Okay, the default is line, but if you scroll down, you'll see that there are also other options like bar, bar H, hist, box, KDE, density, area, and pi. Okay, so there are many different plot types supported by pandas. So the exercise is really, again, I want you to visualize the distribution of comments. So the first step is I want you to figure out what plot to do that. And if you don't know the terminology, you're looking for a plot that summarizes how often particular values are occurring. This is called the frequency distribution. And when you've made this, it should be easy to see, are there a lot of low values? Are there a lot of high values? Okay, so that's step 1, is pick a plot type. And step 2 is, once you've picked a plot, I want you to modify the defaults to make it as informative as possible. So let's pretend you've got one shot to pick the perfect visualization to visualize the distribution of comments. I want you to make it as informative as possible. You don't need to add like labels, but I want you to modify how it looks so that it's as informative as possible. Okay. I am only going to give you about 4 or 5 minutes on this, but I'll be walking around. I'll leave this this doc string up just in case it's helpful to anyone, and then we'll be back up in a couple minutes to talk about it. And I'll. So in the Jupyter Notebook, if you put your cursor within the parentheses, you can hit Shift Tab once, and it will pop it up here. A second time to get it larger, a third time to do I'm not sure what, and a fourth time to get it to appear at the bottom of your screen. And then you can hit this X to close it. So that's how it's done. Great question, and I will do that again so that everyone can have it up. All right. All right. We're going to go ahead and go through this one. Hope you had some fun playing with some visualizations. So, what plot type did someone choose? So, tell me what plot type you used. Histogram, okay. So that's kind of when you talk about a frequency distribution, that's kind of the natural thought of usually. So a histogram, if you're not familiar, it shows the frequency distribution of a single numeric variable. And the way it works is it creates 10 equally sized bins by default between the minimum value and the maximum value, divides those into 10 bins, and then it counts how many observations appear in each bin. Okay? So this isn't kind of the end point, but what have we learned so far by looking at this visualization? Where was that? Well, is that right? So are there a lot with no comments? This person is saying no. And why are you saying no?
The bins that need to be much greater number of bins. There's only 10 bins there, so it's going to be by default. So it's going to, if you're going to spread it out, you're going to see basically put smaller spaces.
Right. Okay, so there's kind of two thoughts I want to get at. One is adjusting the number of bins, which we'll get to in a minute, for that many of you may have thought about already, and if you haven't or are not familiar, you'll see that. The other thought, which is just to make sure we understand this, this is a bin that starts at 0 and ends at about 600 and something. Okay, so this bar represents a lot of talks with between 0 and 600 comments. It's not a lot of talks with 0 comments. So it's not what's at the left. You have to think about the bin itself, which is 0 to 600 and something. And we only know that because the max number is 6,000 and something. So when you divide it by 10, you get 600 and something. Okay, so that's the first thing we've learned about the distribution, is that most talks have a lot fewer than 1,000 or 600 comments. Okay, now what does this not tell us that we might want to know?
How they're distributed within that bar.
Right, so how are what does the distribution look like within that first bar or within that subset? So we've got the reason we have this kind of weird looking histogram, well, weird in the sense that you've got a lot of what looks like empty space, is because there's a talk with 6,000 and something comments, but that doesn't really tell you anything, and it's artificially spread out this histogram. So the vast majority of our data is at the left side, and so my thought is that we don't know whether most talks have 5 comments or 500 comments. We just know that most talks have less than 600 comments. So I thought it would be nice to modify this to be more informative by filtering it down. So we're actually going to filter just like this. TED comments is less than 1,000. Okay? All right? So we're just filtering out everything above 1,000. Okay, so all I did is filter the actual data frame before selecting the comments series. And we've actually only lost a little bit of data. And I'll just show you in a cell above here. So if we do TED.comments, comments is greater or equal to 1,000, sorry, and we do dot shape, we can see that when we filter out the ones with 1,000 or greater, we're only losing 32 talks out of 2,500, okay? So this is my way of getting at a little, like this to me is a much more informative plot because it tells me about most of the data. It doesn't focus on the outliers, okay? Any questions about like how this line of code works or what's going on here? Okay. All right, so before I move on and show you a few more things, I do want to mention that there are different ways you could write this code that would produce an identical plot. So did anyone use the query method? Anyone use query? So it's a different way of writing, of filtering your data frame. So you actually pass it a string, and dot plot kind equals hist. I think I got that right. So this does exactly the same thing using the query method. Some people like using query. And then a third way you can write this, and it's the way I like, and sorry to move things off screen, but that's kind of the nature of this, is I use loc a lot instead because I think it is the most flexible and the most, well, to me, it's the most readable way. It's because it's very explicit about which rows do I want and which columns do I want. So this is not really about plotting. This is just showing you a couple different ways to do the same thing. So this is with loc. So with loc, I select which rows I want, which columns I want, and then run the, sorry, which rows I want, which column, singular, I want, and then plot it as a histogram. Okay. Yeah, please. Right, yes. So loc is great because you can select multiple columns. You can pass it a single column. You can pass it a list of columns. You can pass it a range of columns, literally column A, colon, column C, and it will select A, B, and C, or a Boolean series, and that'll at least work for the rows, and I'm actually not sure about that for the columns. But anyway, yes, there are different ways you can select with loc, which is quite nice. Okay, so the final thing, or well, there's two things left I wanted to show you about this, is what someone over here has already suggested, which is maybe we should increase the number of bins so we can see a little more fine-grained detail. And so instead of sticking with the default of 10 bins, we're going to change it to 20. And now we get a little bit more fine-grained picture. And what we've learned, so now we have 20 bins. Each represent, like the first bin is 0 to 50 comments, the next bin is 50 to 100 comments, et cetera, et cetera. Now we've learned that the most popular, at least in this context, is 50 to 100 comments. That's more common in this data set than 0 to 50. Yep.
So I see that bins isn't listed under plot as an argument. So is
Right.
that calling the hist method and passing bins as a keyword argument?
Right. Yes. So, and a lot of folks, when they were trying to research the documentation, were like, I don't see all these things I want. And if you did like ted dot something dot hist instead of dot plot, you would have more information about that. So, very briefly, and we can talk about it more after, but briefly, pandas is always calling matplotlib to draw its plots. There are many different ways to call pandas plots. There are the generic like dot plot kind equals with a lot of options for keyword arguments, and those keyword arguments ultimately get passed, I think, directly onto matplotlib. But if you want to know what all those are, you unfortunately have to go to the matplotlib documentation. The flip side is you can use things like ted.comments.hist, which allow things like grouped histograms. But the downside is most plots don't have a, dot hist. I mean, there is dot hist, there is dot boxplot, but there's not, I don't think, like dot KDE. And there's so many types of plots that there's not a specifically named one, that I like to teach the dot plot generically because it has most of it, but the downside being you have all these kind of hidden keyword arguments that you don't know what you can put in it, and you end up at the matplotlib documentation like kind of guessing like, okay, I think this one will work here, and then you try it and it usually does work. So that answer your question? Okay, great. The final thing you might think about using here is, did anyone try a box plot? So some box plots, yep. So that's another good way to do distributions, and it's kind equals box. And unfortunately, it's not quite as informative because of what are all the black dots? Outliers. So anything that it defines as an outlier just gets a black dot. There's a ton of things that it shows you. So you can think of this kind of like in a sense, it's like a histogram that's been turned vertically, but it's just showing you your quartiles. But it's got so many outliers that it's not the most informative plot. So I don't like the box plot in this case, but sometimes the box plot is kind of what you're looking for. All right. Before I jump into some lessons, some lessons about what we just walked through. Any questions about this exercise? Okay. And I will say that after the next exercise, which is longer, I'll take a pulse on how we're doing in terms of is this too fast or too slow or somewhere in the middle. But I want to have one longer exercise before you kind of gauge that. So I will be asking, just not quite yet. The lessons that I take away from this exercise, number one is you choose your plot type based on the question you're answering and the data types you're working with. So histograms are good for distributions. Bar plots are for comparing categories. Line plots are good for time series data. Scatter plots are for comparing multiple numeric variables. So yeah, you have to choose based upon the type of data you're working with. And pandas actually has a lot more plot types than are represented in that kind equals. So if you're really interested, I would encourage you to read the visualization page of the pandas documentation because it has tons more plots and you call them, unfortunately, in an array of different ways. But there are actually a ton of supported ones. So that was my first lesson. My second kind of takeaway is I like to use pandas one-liners to iterate through plots quickly. As I said, pandas is calling matplotlib under the hood, but it's generally faster and easier to write pandas plots than matplotlib plots. The downside being that this advice is mostly relevant for exploratory plots because there are limits to how much you can customize it without using matplotlib directly. Okay. The third lesson I wanted to impart is just to try modifying the plot defaults because it's rare that the default settings are going to give you exactly the plot that you are looking for, the most informative plot. And the final takeaway, especially for anyone who is uncomfortable with the idea of like, let's just cut out these 32 observations, which is what I did. Creating plots involves decision making. In fact, a lot of decision making because you can't show everything on a visualization. A visualization is inherently a summary. So you have to accept that you're not going to show something. There's no single correct way to visualize a certain piece of data. So there's no right or wrong visualization, but there are certainly misleading visualizations. And it's very easy to create a misleading visualization, even accidentally. So your decision should be guided around, how do I accurately answer this question and not mislead folks as to what's going on in the data. Okay, so those are the takeaways there. I'm going to jump into the next exercise, and this one is going to be, as I mentioned, is going to be longer, and hopefully you will like kind of, if you found those to be easy, then hopefully you'll struggle a little bit at least. So this is number 4. Plot the number of talks that took place each year. Okay, number 4, plot the number of talks that took place each year. And I choose my words very carefully, so look back at that if you're unclear. I'm not going to give you any advice this time. I do have a bonus for anyone who finishes early. I will just raise your hand and grab me. I am going to give you about 12 minutes for this exercise. Okay? And again, always grab me while I'm walking around with your questions. 12 minutes. But I'd like to just see, just a quick show of hands, how many folks would use more time if they had it? Oh, okay, almost everyone. So at least a couple, we'll do at least a couple more minutes, and then I'll kind of make a decision. Yeah, ask a neighbor if you're stuck on one part and you're like, I just can't get. Ask a neighbor and see if they can just tell you, and then you can move on to the next part. Okay.
Yeah, so I've gotten the date and year, and I've gotten it to group by year. But, I think so. So I got it from the film date. So I think it's a Unix timestamp. So, yeah, I think the unit S should.
I certainly asked, but I realizing what it should be very different in my level of programming. I went to the event page,
Get,
took a shortcut.
yeah, so it'll give
I'm
you
sure it's not.
dates, and then you can extract the date or the year from the date.
So it's UTC timestamp, Unix timestamp.
At first I had done, well, at first I thought it was really clever because I made a column that extracted the year from the event by taking the last four of the event.
Oh, yeah.
So like, at first I was like, oh look, I got it, see, by year and everything. But then it gets down and then you're like, all these other ones that, I was like, oh, never mind.
Awesome. That's a cool way to do it.
Look, the file itself doesn't care. It's just looking
Yeah,
at
you
the
need to
values,
use two date time functions.
but I can't figure out how to
Ah, this
convert
is
those
better.
into
Look, he was
dates
this
for
is
the
2006. So I just started saying it to that guy.
What column are you using? Oh, published date. Yeah, so you could also use film date. There's two of
That
them.
gives you a specific answer. Your start date. It looks like 1984, at least from the way it did it before.
I have stuff going back to.
Oh, I just year first equals true. Sorry, I was playing with other.
Yeah, the first one started in 1972. Why Blue did others. But it's also like this isn't. I don't think this is sorted.
Yeah.
So it might be a.
Oh yeah, yeah. Now it goes back. Yeah. Just column.
All right, this is, I think I'm going to go ahead and cut you off on this one because there are some sticking points that a lot of people are running into, and I don't know if you'll get it even if I give you like a really long time. So I don't want to just spend all day. No, and that's not, I mean, this is hard. Like, this is hard. If you have to know, I mean, I have to guess what you might know, and that's what I'm using when I create these exercises. So if you don't know certain key things, this would be very, very hard. So anyway, with that being said, let's go through it, okay? Let's see here. Okay. So what is wrong first with using the event column? Did anyone try the event column and then they got stuck? Why did it work or did it not work? You were.
I mean, it's just the last 4 characters in the field.
Okay.
Meaningful.
Now, in what cases would that did that always work? And the answer is no, but can someone tell me why the answer is no? Some of them don't have the year. So this is, if you're not familiar with like the random sample method, that's useful. So, you know, I just want 10 randomly selected events, and you'll see that some of them end with a number that obviously represents the year, and some of them don't. So if you go to that column, you are going to get stuck. You're going to have at least a lot of missing values because you're not going to have the year. So what I was hoping you would do is go over to the TED Talks dataset website, and you would scroll down and you would see film date, and you'd see it's the Unix timestamp of the filming, and that sounds like, well, that's when it took place. So that sounds like the right column to focus on. So let's take a look at it. Film date.head. Okay. And we've got our Unix timestamp. Okay. So I look at that and I think, well, I don't really know much about Unix timestamps or what to do with them, but my, pd.toDateTime, which was a key function here, if you did not get to pd.toDateTime, that was like a big something you needed to make this easy. So pd.toDateTime converts a series to the datetime format, and it does a lot of guessing as to what format it is and produces pretty good results. Now, unfortunately, these don't look like good results, which is disappointing because usually you stick in whatever and out comes the real dates, and you're like, wow, that's magical. But in this case, it did not work. Okay? So here's what I was hoping you would do, and I know this is a stretch because you'd have to happen to follow this same sequence. But if it was me and you know what toDateTime is, you would Google pandas toDateTime, do toDateTime, and you might go looking to Stack Overflow, and you might stumble upon a good answer. But in this case, I would get here because I know I want to use this function. I would search for the word Unix. Whoops, Unix. And I would get down at the bottom, I would find this, which is an example of using it to convert something that looks like our timestamps to something that looks like what we want. And all they did was say unit equals S, and magically they got the right thing. So my thought was, well, let's just add unit equals S. And then you get these dates that look like, hey, that looks like the right date. So what I did, and so if you didn't know about toDateTime, getting to this step would be very hard. But if you did, then what I'm hoping you did is created a new column, because it's best not to overwrite your existing column unless you're sure you don't need it. So I'm going to create a new column called film datetime, okay, with this data. And then they looked like the right dates, but I would want to verify that this is like, that it worked as we had hoped. So what I'm actually going to do is just pull out 2 columns, event and film datetime. So I'm pulling out the 2 columns that one is the one I just created, and the other is one that has a name that often includes the year. And I'm just going to randomly sample. And when we do that, you're going to have a different random sample. But you're going to look at it, and you're going to say, OK, the 2012 event has a 2012 film date time. Same thing with the 2007 and the 2008 and the 2015. And so you think, OK, that probably did work. So we don't want to assume it worked just because some rows looked like they were correct. It's good to use a random sample to kind of verify your results. Okay? Now, the thing it's done, we're going to check the D types, again, of the entire data frame. And the thing it's done is create this new column called film date type, Okay, sorry, it's created the new column called film date time, and it's using the date time data type. So that's a special pandas data type that is automatically output when you use pd.toDateTime. Okay, and I'm just curious, like how many people this is completely new to them using the. Okay, at least half the room. Okay, okay. So the neat thing, so basically, if you want to get a I'll show you'll see why you want to have date time data types. But anytime you use pd dot to date time and pass it something, it will output a date time column. And that's useful for a lot of reasons, and I'll show you one reason right now, which is Ted, if I select film date time, then I have this little DT namespace, and I can select convenient attributes like year, okay? I can select day of week, I think is one. I can select day of year. And all these convenient attributes are available under this little .dt namespace because it's the datetime data type, okay? So this is the easiest way to get the year. There are other solutions to this exercise, but this is a good one. So now we've got this .dt.year. Now, if you're like, wait, that looks kind of familiar. This is the same as like string methods have this little stir namespace, like stir.lower. So if you want to do string methods on a series that's a string, you do column.stir.string method name, and it will do it. In the same way, with datetime data types, you have this little DT namespace with a variety of convenient attributes you can pull out. Okay? So I've got this year data. So I've got everything I need in this column, year, which is what we were going after. How do we count the number of talks per year from where we are here? Value counts, whoever said that. So yeah, the value counts method is good anytime you want to count values. Okay? Now we've got our value counts. And now that we've got the data that we're looking for, which is the number of talks that took place each year, what kind of plot do we probably want to use? Bar plot is one suggestion. Anyone want to offer an alternative? Someone said histogram. Someone said line plot. Okay. So a bar plot is okay, but there are two things. Well, let's do it, and then we'll talk about it for a second. And, whoops. Obviously, I need to actually dot plot. Sorry. Value counts dot plot. Okay. So we get this, and yes, we can fix up the sorting. But the thing, there are kind of the main issue here with using a bar plot, other than sorting, which we can fix, is that it's excluding all the years that did not get that are not in the data. So there was no talk in 1973, but there was in 1972. But a plot that misses those time spans is a little bit misleading because you can't see the jumps. Now, bar plots are best for categorical data. And technically, you could consider years to be categories, but they're not really, or it's not optimal. And a line plot is better because line plots are for things that are plotted over time. Okay? So a line plot is better in this case. So what I'm going to do, the line plot is the default. So I'm just going to run this. And I want you to tell me what went wrong here. So this is not the answer, but what went wrong? Something about sorting, and who can tell me more? Tell me a general principle about why this plot looks the way it is. Like, what is it doing that is non-optimal? Yes. Why is it doing that is the question. It is, yes, it is forming a continuous line, but there's something more to it.
It's because it's not interpreting the year as an integer.
That's actually not the case. Over here,
My guess is that it's plotting along the wrong axis.
it's not plotting along the wrong axis. These are great. Obviously, this is a great question because I'm not getting the right answer.
You just like the data frame, how each row is placed in the data frame, and it looks like it's sorted by the y value. So the line is connecting from the highest y value to the lowest.
Right. Okay. So it is a sorting issue, and let's look at the data. Okay. Let's look at the data. If I take this and I give it to dot plot, which produces a line plot, pandas will plot them in the order in which they appear. So it will first plot 2013 270, then it'll plot 2011 270 and connect it, then it'll plot 2010 267, and if you actually follow this, you'll see that that is why it produces this plot. So it plots things in the order you give it to them, okay? Now, if we want to fix this, we're just going to do sort index, okay? So we're going to throw in sort index, and actually let me show you that before the plot. Sort index sorts the index, which is the thing on the left, not the values, which is the thing on the right, okay? So you want to sort the index because the index is going to become the x-axis and the values are going to become the y-axis. But because it's connecting the points, you need those points to be in order. So when we do that, we get the plot that I was actually looking for. So this is one way to go about getting this particular plot, and there are others, but we could talk about that all day. I do have one question though. Is the number of talks on a sharp decline? You say no, and why do you say no?
Probably just the last year isn't complete yet and doesn't have all the data.
Right, so there's some incomplete data, so you don't want to draw a conclusion that there is a big drop just because there's a drop in the plot, because it turns out that if you use film datetime dot max, so you can use things like max and min with your datetime data types, and you see that this data ends in the middle of 2017, which is why we have incomplete data for this particular year. Okay? Yeah, please.
So, supposing the value of there were no talks in 2010.
Oh, sorry, say that one more time.
There were no talks in 2010.
Okay.
Would this graph go through 0 in 2010?
Good question. In this case, it would not. And there's a different way. So there's like multiple ways you can go about. There are, if you use, I don't know if you're familiar, anyone familiar with resample? Resample? Okay. So I won't go into it because I don't want to stray too far. But resample is another way you could solve this problem. Essentially, you resample it by year. And then you do a count of observations of any column. And you'll end up with roughly the same plot, except it will handle 0 years slightly differently, which is probably slightly better, but it depends on what exactly you're trying to show.
I would make a data frame with missing values and merge that with this thing by year. And then the merged value would have missing values for the years and missing values to zeros.
Oh, interesting. Okay. So it's not going to, there aren't any missing values in this case. So a 0 isn't a missing.
There are no observations 2010.
Right.
Missing value in that series.
Okay. Got it. Got it. Yes. So I don't know how plotting, I think plotting would just, I'm actually not sure how plotting would handle a missing value in that case, but it's a great question. I just don't happen to know. Other questions about this particular exercise, and then I'll go through some lessons. Yeah, please.
So I'm a little confused. So you looked at the plot that I had before, which
Right.
showed no talks before 2006.
Right.
So I created that by mapping the datetime function to
Uh-huh.
that row.
Uh-huh.
It's converting a Unix timestamp to a datetime object.
Okay. So your question is essentially you're wondering why yours ended up without anything below 2006. Okay. Let me take a look at your code during the break and see if I can figure it out. But
I was gonna say, I had the same issue. I
okay.
used publish date instead of film date.
Oh, you use publish date. Okay, that might be it. So publish date and film date are actually different, though I don't know how far back the publish dates go. Oh, okay, well that solves it. So that is a tricky little piece of, it's why I phrased it as the number of talks that took place each year, so that you would kind of choose a certain way, but it's an easy mistake to make. Other questions? Yeah, please.
Mapping the from timestamp method in datetime less efficient than the to datetime method in pandas? Like, is there any?
What's the name of it from?
So the datetime library in Python has
Okay.
datetime.from timestamp.
Got it. Okay. So it is probably, so most things in pandas, as long as you're calling them directly and not through apply, which we'll talk about later, are going to be more efficient than anything else you can just pick out of a different library, because pandas overall is well optimized. So it's probably less efficient, but it's more that like the functionality in to-date time is really nice, and I know it works really well, and there's a ton of options. Now, there might be more or less options in the library you're mentioning, so sometimes you might need to use it, but in this case, all we needed was to say unit equals second, and we got what we needed. But great question. Other questions about this one? Okay. So a couple lessons, and then let's see. Okay. A couple lessons I wanted to go through as to some takeaways. And first takeaway is read the documentation. So in this case, the documentation for the data set as well as the pandas documentation would both be useful to you. So it's a good resource to use. The second lesson is to use the date-time data type for dates and times. So number one, it works well with plots. Number two, it provides convenient attributes. And pandas actually has extensive functionality for working with time series data, but that functionality depends upon you using these specialized data types. So the takeaway here is if you have date and time data, it will serve you well to use the date time data type. Lesson number 3 is check your work as you go. So hopefully, that I use the random sample method in order to spot check that certain conversions are working properly. Rather than just looking at like the head or the tail, I like to use a random sample. And then the fourth point here is to consider excluding data if it might not be relevant. So as we saw, we only have partial data for 2017. You might want to consider excluding that. It depends on what you're trying to show. It turns out that some of the talks from the TED website, it was scraped from the TED website, some of the talks on the TED website actually were not TED Talks. They're just like talks that they uploaded because they thought they were really TED-like talks. The TED conference was actually founded in 1984, not in 1972. So you might want to consider, like, if someone asked you this question for work for some reason, it might be a good idea to research, are all the talks in the data set actually TED Talks? And do I want to include data that is non-TED Talks on the TED website? And that would depend on what question you're trying to answer. So yeah, that's really all I want to say about that, is sometimes the data you have, you should exclude certain things depending upon what you are trying to get across. Okay? All right. Yeah, please.
Question about date-time conversion.
Yeah.
Is there a way to do the dot notation on an arbitrary integer treated as an epoch time dot as type date?
Oh, he's asking if you can do conversion through using like as type in the same way that you have a column of strings that says like it's a string of the number 3. You can just do like as type int and it will become an integer column. I think it would be a good thing if there was like as type date time, But as far as I know, that does not work. There's no, like as type does not support that particular conversion. So you have to use this pd.toDateTime, which is this top level method. It's not like a series method or a data frame method. It's just this top level function, actually. Other questions? Okay. So let's see. I think what we're going to do, so we've got 12 minutes till the break. So I'm going to start you on the next exercise, and I think I'll just let you go to the break working on that, and then we'll talk about it afterwards. It might put us slightly behind, but I may start talking about it before if I feel like it. So anyway, you're going to have at least 8 minutes for this one. And let me go ahead and type it out and let you get started. Okay, this is number 5. Whoops, 5. What were the best events in TED history to attend? Okay. What were the best events in TED history to attend? And I'm not asking about the best individual talks. I'm asking about the best event, that event column that's like TED 2006, TED whatever. So what was the best event in TED history to attend? And it's your job to figure out how to define best and then use that definition to calculate which event was best, okay? So I'm going to give you at least 8 minutes, but I will more likely give you until the break at 3 o'clock, and then we'll discuss it after. And if anyone finishes early, I have a bonus you can work on. But yeah, go ahead and get started. let me give one quick piece of advice. Is start with a simple-ish solution. If you have multiple ideas, try to execute a simple one first and then increase your complexity, just in case you're heading down a path and you decide you don't want to be there. So just start with simple and then add on complexity if you like. Yeah, I'll just leave it at that. Just give you a preview. So it's 2:57 right now. So the break is from 3 to 3:20. I'm not going to talk before 3:20, but at 3:20 sharp, we are going to start, and I'm going to start explaining this exercise. So if you need still more time on this, then feel free to work on it a bit during the break. But you're welcome now or in 2 minutes at the start of the break to head out. But we are starting back at 3:20 promptly, okay? 2 more minutes. 2 more minutes and we will get started. All right, 3:20. We are back. Cool. Hope everyone had a good break. Okay, so what were the best events in TED history to attend? Before I start going through this, just wanted to hear what a couple folks had as ideas. So if you want to just raise your hand and share the idea you had. Yep.
Count the jaw droppings in the ratings.
Count the jaw droppings in the ratings. Okay, all right.
I did something similar, except I sort of subjectively decided which of the ratings were positive and which ones were negative.
Okay.
And I calculated the percentage of positive reviews based on count.
Okay. Now, so for each talk, you're calculating the percentage of positive views based upon those ratings, and then are you taking that? How are you using that to judge events as a whole?
So then I aggregated by event, and I'm sure that I didn't do that the best.
Okay. So she aggregated by event at that point. Okay.
I didn't really come to a conclusion, but what I realized is that a lot of the events have very few talks,
Okay.
and some have like a lot. So that's kind of the path I went down.
Got it.
I made sure that the event that was considered the best had a lot of talks.
Got it. Got it. Got it. So he was didn't come to a conclusion, but noted that some events did not have many talks, and that seemed like it should be factored in. Yep.
Yeah, I did something similar. I looked at views per talk.
Okay.
So views. So I did a scatter plot of both. So that way
Okay.
you don't have that many views overall, but you had a lot from the number of talks you had, and you could still be one of the best events.
Okay, a scatter plot of views versus views per talk. Views versus, okay. Yeah, back there. The minimal number of views to get a positive comment. But you won't know. Oh, okay. Okay, I halfway understand that, but I won't dig too far into that. Okay, lots of great ideas. I really like this. You may be disappointed that I came up with something simpler than most of these, but have built upon some of these ideas, which is fine. And we're actually going to get into the ratings data because I think it's interesting. We're going to get into the ratings data in the next exercise explicitly because I want to show you some stuff with that. But we're actually not going to touch ratings for this particular one because I stayed away from it. Okay, so thank you for sharing all those ideas. But so one idea that no one mentioned, but I thought was worth considering is just like, hey, why don't we just count the number of talks? Because this is not my complete answer. But, you know, a good event has a lot of talks, and if you have a lot of talks, you have some variety. So if all you care about is variety of talks, then this is not an unreasonable way to value, to go about thinking about this question. But then I thought, well, we want to know about talk quality. And the talk quality proxy measurement, I thought, would be views, because someone viewing it online is kind of like a vote for the talk. Doesn't mean the talk is great, but there's something to that, because we want to know about talk quality. We don't have data. I mean, we have the ratings data, which you can use. It gets a lot more complicated. But I thought views would be an interesting way to start. So I did a group by. So I thought, because ultimately we need to aggregate based upon event. Okay? So I used a group by, and then we'll talk about group by in a second. TED.GroupByEvent.views.mean.head. So I did a group by. So the template for using a group by is for each event, I want to do some aggregation function on some column. So I have a category that goes in your group by. For each category, I want to do some aggregation function, in which in this case is mean, over some particular column, which in this case is views. So this is the average, or the mean number of views for each event. Okay? Now, let us go ahead and sort this, because this is just sorted in alpha order. So let's do sort values.tail. And we see that TEDx Puget Sound had on average 34 million views per talk. So that must have been one amazing event, because they averaged 34 million views. But as this gentleman over here mentioned, some of these events only have a few talks in them, which would seem to be relevant. So if I'm looking at this data and I say, well, TEDx Puget Sound may have been a great event, but I want to know how many talks were at each of those events, what would I do? How would I modify this to see that data? Anyone know offhand? That would not, you can group by two things, but you wouldn't get what you're looking for. There's a different approach, or a slight tweak on that will give you what we're looking for here. One more time? So .ag, so what we're going to do is, you may not know that, so this is mean as an aggregation function. You may not know that you can do multiple aggregation functions here. So you actually just do .ag, okay? .ag, which is short for aggregate, and then you pass it, you actually pass ag a list of functions. So we want count and mean. So I know the notation is a little tricky here, but we're grouping by event, we're selecting views, and then we want to say we want to aggregate separately on count and mean. All right, so we're passing it a list of the functions we want to aggregate on, and then we want to, actually, let's just do that to start. Whoops. What did I do? Sort by. Oh, okay. So now that this is a data frame, I need to specify what I'm sorting on. So we're going to still sort on mean. And we still get that same mean column we got previously. Previously, the output was a series. Now the output was a data frame. We have count and mean columns. And we can see that, yes, indeed, TEDx Puget Sound had 34 million views per talk on average, but there was only one talk. So that would not necessarily be the best event in history. It was probably quite a good talk. And I doubt that was actually the only talk. Maybe that was the only talk they uploaded. Who knows? We don't know how they decide exactly what to put on the website. So this seemed like a good direction, but didn't quite get what we were looking for, which is TEDx Puget Sound was probably not the best TED event in history. So my new idea, and again, this is just one way to go about things, is, sorry, I'm having a little, what? Okay, sorry. My new idea, sorry, I'm having trouble with selecting the text, so I'll just copy and paste, was to add in another aggregation function, namely sum. And my thought here was, well, how about we look at what events have had the most total number of views? Huh. And sort by sum. And this is what I ended up with, okay? So TED 2013, across all of their talks, had 177 million online views. So perhaps that's some proxy for quality of talk, in that lots of people after the fact have been watching the talks. Now, there are some definite weaknesses with this approach, namely, like we've discussed previously, views are biased in favor of older talks that have had a lot of time to accumulate views. And of course, talks with lots of views are not necessarily good talks. Maybe they're bad talks and people are sharing them just to say how bad this is. More likely, they're probably good talks, but we don't know that, which the ratings data might be able to help us out with. Okay. I'm going to just talk briefly my couple lessons to take away from this, but any questions about this exercise before I do that? Okay. So the lessons that I would take away here, think creatively for how you can use the data you have to answer your question, because you're rarely going to have the perfect data set to answer a particular question. So think creatively. But when you do that, always acknowledge the weaknesses of your approach. So explicitly say, well, I summed based on views, and here's the weakness of that approach, but it's the best approach I could come up with. And if you can't make it work with the data you do have, sometimes you should just not answer the question or go gather additional data. Okay. And then the second point is watching out for small sample sizes. And as I like to say, use count with mean to look for meaningless means. So if you find yourself doing a lot of group by something, select something mean, and you do that a lot and you rely on that, make sure that you actually have a lot of data you are taking the mean of, because it doesn't tell you. But if you throw it in that, if you throw in the ag, it'll become a data frame and you have multiple columns you can look at. Okay, here are the sample sizes I'm working from when I do this. Okay? All right. Let's go on to the next exercise. And actually, this exercise, which I'm calling, unpack the ratings data. So this is actually going to be a fully guided exercise. I just want you to follow along, and I will kind of lead the way here. So let's take a look at ratings, which a number of people mentioned in the last exercise, ted.ratings.head. So ratings, there used to be a way on the TED website to tag talks, for visitors to the site to tag talks as funny or ingenious or boring or inspiring or any number of things. Now that functionality doesn't exist anymore, but anyway, the data set was scraped while it was still available. So we've got this ratings data, and let's take a look at that first line, okay? So I want to look at this first line to understand what's in it so we can figure out what to do about it if we want to access it. So one way to do this is to use the loc accessor, and I say, what row do I want? I want row 0. What column do I want? I want ratings, okay? So that's one way you can do things. The other way I'm going to do it, which is maybe a little more familiar, is just to select the ratings series and then select element 0 in the series. Works just as well. So that's what I'm going to use, but you can do either way. Okay, so here are the ratings of the first talk in the data set. And what is the data type of this? Oh, some different answers. We've got string and array. Any others? List of dictionaries. Okay, well, let's find out. And string it is. All right, let's look at it again. This is a stringified, is the technical term, a stringified list of dictionaries. That is not a list of dictionaries. That is a string representation of a list of dictionaries. So, can anyone tell me the absolute simplest way to unpack this data? Eval is I know of one really easy way. There might be multiple, but I heard eval, which is very close to what I'm going to do. I mean, it might be the same thing, just in a different way. That, oh, I don't think that will. No, I don't think that will work. But I don't think it understands stringified objects. Oh, replace the single quote with double quotes and load as JSON. Oh, maybe that works. I have not tried it, but that's an interesting strategy. I will tell you a generic strategy, which is AST. It's a module that stands for Abstract Syntax Tree, and it has a function called literal eval. Okay? Literal eval, and I want to show you an example, and then we'll actually do it. So if I have, so if I pass literal eval a string that looks, there we go. I passed it a string that looks like a list. It returns a list, okay? I passed it a string that looks like a list, and it returns an actual list, okay? So that's our magic function. Literal eval allows you to evaluate a string containing a Python literal or container, okay? So if you have a stringified integer, you can use it. If you have a stringified list, you can use it, and that's the magic of it. So that's what we're going to use. And what I'm going to do is try AST literal eval TED.ratings 0. And it looks much better now. This is not a string. This is now a list. Okay? This is an actual list. It turned our stringified list into list. So now what we want to do, now that we have a list, we want to we actually want to apply this to the entire series, because this is the list of dictionaries of ratings for a single talk. But we want to do this for all talks, okay? So the spoiler is we're going to use apply, and I'm going to define a custom function, and then I'm going to show you a different way using lambda. But if none of those are familiar to you, that's totally fine. So what I'm going to do is define a custom function, and I'm going to call it stir to list, and I'm going to pass it something called ratings stir. So the goal of this function is to take in a ratings string, which is what it starts as, and then convert it to the list, which is what it represents. So all we're doing in the function is return ast.literal eval ratings stir. Okay? So there is my function. Now I always like to test my function and stir to list and TED.ratings 0. Okay? And that looks like it worked. Okay? So I've defined this custom function. I believe it works. I want to apply it to every element in the ratings series. So what you do is use an apply function, or the apply method. So I'm going to say TED.ratings.apply and pass it stir to list. Okay? And let's just look at the head of that. And looks like it worked. I mean, it looks pretty much the same as before, except those are actual lists instead of strings. Okay? Oh, sorry. Please. Right. So after I show you this way, I'll do it with a lambda. And then that is essentially, that's, I believe, what you're asking. That would not. Oh, actually, that might work. Let's actually try. Oh, look at that. You're right. That is a superior method. Thank you. I will finish showing you what I was going to show you because at the very least, for anyone who's not familiar with using apply and lambda, I do want you to understand how lambda relates to custom functions. But in this case, my lambda doesn't do anything special other than pass a function with no arguments. So in this case, he's absolutely right. I could have just passed this. Good point. Thank you. All right, let's see. So what I'm going to do is store the results of this, and I'm going to change back to my function just for fun. But you don't have to. I'm just very attached to my function that I've made. So we are going to create a new series called. What am I going to do? Actually, let me show you the lambda version, and then we will save it, okay? So the other version of this, anytime you have a really simple custom function that you're passing to apply, you can use something like lambda, and it looks like this, x, and this, the nice thing with lambda is if my function had arguments to it, then you can include that in the lambda. But because there's literally nothing going on except do this one function, the lambda is clearly not strictly necessary. But this is the general format of the lambda function. Lambda x just kind of becomes every element in the series, and then you say for each element in the series, do the following thing to it. Okay. And again, it looks like it worked. So finally, we're actually going to just save this as a new column. Now, I will pause and just say I do want you to create this column. So if you've just been watching up to now, go ahead and type in this code. And as he pointed out, you don't actually have to use the lambda, or you can. But I do want you to create this column because it will be needed for the next exercise. I'm calling my new column ratings list. Okay. And we're just going to check that again. We're going to check that it worked. ted.ratingslist 0. Okay. So the goal here is to take our ratings, which was a series of strings, and turn it into a series of lists, okay? So as we talked about at the very beginning, you can actually put arbitrary Python objects in a series. So this is I want to just prove to you that this is a series of lists, okay? That is an actual Python list, okay? And if you go back to the data types, ted.dtypes, you will see that the ratings list is an object column, but it is not a string column. It is a column that contains lists. Okay? It is a column that contains lists. All right? Okay. So that's actually. Oh, please. Oh, sorry. Never mind. Any questions? Yeah, in the back. Right. So I studied this. I did. I mean, I researched things like that like a year ago and concluded that map seems to have a subset of apply functionality. I don't know if there are things you can do with map that you can't do with apply. There might be. In my head, I've just decided I'm going to use apply when I want to apply a function to a series. I'm going to use map to essentially do a dictionary mapping of A to B. You know, A becomes 1, B becomes 2, whatever. So that's how I use them. But it is confusing that they have very overlapping functionality. Other questions? Yep.
I was going to add what's confusing about map is if you do it to a series, it maps the function, but if you do it to a data frame, it maps by element, not by row, whereas apply does it by row.
Right. So there's just to kind of summarize, and this is actually that actually leads right into one of the lessons. And actually, let me jump over to that. And I'll start with number 2 first. So apply is super powerful. The lesson is use apply anytime it's necessary. So apply is often discouraged because it's slow compared to built-in pandas operations. But sometimes you don't care about performance, number 1. So why not use something that's working? But I would say use it last rather than first. So don't use apply if there's a built-in function that can do the same thing. Built-in pandas functions are going to be faster, they're going to be more reliable, and probably better designed and documented and tested. The confusing thing about apply, which is my comment on her last comment, is apply is confusing because there's the series apply method. There's a series map method, which has some of the same functionality. There's a data frame apply method, which is different. And there's a data frame apply map method. Apply map, one word, which is also different. So I've got a video about this if you really want to understand them. But the bottom line is apply gets confusing. So be careful, and apply gets a bad rap for performance, but that's okay if you don't care about performance. Okay. So that was lesson 2. Lesson 1 is just paying attention to data types, because data types impact every aspect of pandas functionality. You have to know what data types you're working with all the time. Otherwise, you're going to use the wrong functions, or you're going to miss out on functions you can use. Okay. All right. Let us jump in to the next one. All right. So this one is back to on your own. So this is number 7. Count the total number of ratings received by each talk. Count the total number of ratings received by each talk. And I want you to store that in a new series called, a new data frame column called, new column named num ratings. Okay? So count the total number of ratings received by each talk and put it in a new column called num ratings. Your hint is use what we just learned. And if you finish early, let me know and I will give you a bonus. I'm going to give you 10 minutes, maybe slightly less, 8 to 10 minutes, and then we'll go through this one. Okay? Sorry to interrupt. So already a couple of folks have asked for the bonus, so obviously there are some folks that are blazing through this one. So I'll just tell you two ideas, and if you anticipate finishing early, just write them down. So the first bonus is for each, we're not going to go through it, by the way, this is just for you, but for each talk, calculate the percentage of ratings that were negative. Okay? So that's one idea. Another bonus idea is for each talk, calculate the average number of ratings it received per day since publishing. Okay? So that's a couple more steps. Sure. I'll put them on screen. right, we're going to go ahead and go through this one. Hope you enjoyed that. So obviously, some folks blew through this in the first minute or two, so I realized that this was easy for some folks, but I don't want to presume that. So let's start by talking about what we wanted to accomplish. So we have TED ratings list, and we've got element 0 in the ratings list. So this is our first record. And the goal we're trying to accomplish is to sum the count, right? If you were trying to do something else, you went off in a different direction. But that's what we were trying to do, is sum the count. So I'm going to build a function to do this, a custom function, and then I'm going to use apply. And I'm going to build the function in pieces because that's how I build functions. For many people, you might look at this and you can just write it in one shot. It's like instantly obvious to you what to do. It's not as obvious to me, so I'm going to build it in pieces. So especially for anyone who's a bit newer to programming or Python and wants to think through how to write a function. So what I actually tend to do is I kind of always define like a minimum function that doesn't do what I want to do, but it gets me closer, and then I build it up in pieces. So I'm going to define a function called get num ratings, and I am going to pass it what I'm going to call list of dicts, and all it's going to do to start is just return list of dicts 0. Okay? And that obviously does not accomplish our goal, but I want to make sure I understand the data structures. So when I pass it TED ratings list 0, I want to make sure that I get out a dictionary. Okay, I'm going into the data structure. I successfully pulled out the first dictionary in the list. Okay, so it's getting me closer to my goal. So then my next kind of step is to say, okay, I want to pull out the count from that dictionary. And I rerun the function. And then I run it. And then now I'm pulling out that count, that number. Okay? So I'm close in that I've pulled out one of the numbers I want. But what I really want is to iterate through the dictionary and get all of those numbers and sum them. Okay? So I'm going to revise this function to give me actually what we want. And if you didn't get this on your own, I'd advise you to copy this because it might be useful for the next exercise we'll do. But basically, here's how I did it. I just started a counter called num. Okay? And then we're just going to iterate through our list of dictionaries. For d in list of dicts, okay, I'm just saying num equals num plus d bracket count, okay? So, and then in the end, we're just going to return num, okay? So those temporary steps I took were just to make sure that I understand the fundamental data structures so that when I dive into them, I'm getting the right. Oh, thank you. Thank you. All right, I think I got that. And now we'll run it. And we get a number that looks reasonable based on the data we saw, 93,000 votes, okay? And what I advise doing is, if it's not too hard, you can spot check that it worked by like kind of adding this up in your head, just the round numbers, and seeing if you get about that. Another way to verify that it's working would be to pass in a couple other records, see if what the results you're getting look good. But I believe this is a good function. So because of apply, all we have to do is do TED.ratings list.apply get num ratings. Okay, so now that I've got a working function, I can apply it to that series. Okay, and I get numbers that seem reasonable. Okay, they're not all the same number, which would indicate a bug in your code. There's not a bunch of missing values. There's no zeros in there. These values make sense. Okay, and because of that, I'm going to go ahead and store these in a new column called num ratings. So if you did not do this on your own, I would advise also typing in this line so that you create that new series. So again, here's the function. we applied it, we saved it in a new column called num ratings. And just for fun, because I like to do lots of spot checks, one thing I might do would be ted.numratings.describe. Okay. And that just allows us to check, oh, well, 2550, that's the right number of values. A minimum of 68 sounds reasonable. A maximum of 93,000, well, we saw that one, so we know it's reasonable. We're not seeing any negative values. We're not seeing any zeros. So we're always just looking to see, I think I did it right. I can't prove it by I'm not going to manually do the math for every row in the data frame, but I can at least do things to kind of check that my results make sense. Okay? That's the end of this exercise. I'll go into the lessons in a moment. Did anyone do this exercise but with a lambda? I wasn't sure if it was possible. You did. And it worked. Is it complicated? Okay. Maybe I'd like to see that because I wasn't actually sure exactly how to fit all that into a lambda. But oh, okay. Oh, right. Of course. Okay. All right. That makes sense. I would like to see it regardless, but yeah, please.
So I'm gonna out myself for how much TED I watch, but look at the list of the top 5. I think all of them, except for maybe the last one, are on the most watched TED Talks.
Oh, cool.
Best TED Talks of all time.
Nice.
Playlist on TED.com.
Cool. Cool. Yeah, please.
Just one thing, you can do pandas.dataframe or pt.dataframe.
Right.
And just pass in the list.
And you can pass in.
So if you go, if we go back up, so we'll take a list of dictionaries, what do you get them? Maybe take, the pandas of 73, pt.dataframe _ 73.
Like this? Is this what you're? Okay. Oh, interesting.
Take the results of that.
Oh, nice. Okay. Oh, right. Right. Okay. So just one teaching point. I was about to do this, and who can tell me why I can't do .count.sum? So count, you can't, so I use dot notation all the time, but I also understand the limitations, one of which is if a column name, so this is a data frame, a column name conflicts with a built-in method, you cannot use dot notation, which is why some people don't teach it, but I just like it so much that. So in those cases, you have to use bracket notation, and I just don't like bracket notation. It's the bottom line. And there you go. Oh, great. Very cool. I had not thought of that.
And then that gives you your lambda.
Right. Ah, okay. You can. Oh, wow. Cool. Well, thank you. I appreciate that, and I do still want to see the other version just for my knowledge. But that's awesome. I love it. Any other comments or questions?
Just to expand on that, or if you want to eventually do sort of like that, have each of the separate tags be columns, if you apply that data frame without doing the sum, you can basically get the data frame where each of the tags has been broken out. If that makes sense.
I might have to see that. I'll actually, so we've got one exercise left and it's pretty substantial. So I'm going to kind of move us along, though I am interested to see more about this. And I appreciate it very much. I just want to make sure folks have a long time to work on the last one. Just to briefly go through the lessons. I mean, really, these are more kind of general principles of mine. Write code in small chunks and check your work as you go. So that's how I write things. Check whether results are reasonable, and it's easier to detect when bugs are entering your code if you're writing in small chunks. And then to me, Lambda is best for simple functions, though it sounds like it still is pretty readable using the Lambda, and certainly the one that he showed was pretty readable. So anyway, those are my lessons for that one, but I really want to dive into the last exercise because it's a bit more substantial and a bit more creative. So let's get there. It's number 8. Which occupations deliver the funniest TED Talks on average? Okay? Which occupations deliver the funniest TED Talks on average? Now, this is, as I mentioned, the final exercise. This is a multi-step process. There's not one correct way to do this, but I will show you a way to do this. I would definitely encourage you to check your work as you go, and as before, watch out for small sample sizes, okay? I am going to give you 15 minutes, maybe a few more, but probably just 15. And I'll type up some bonuses on the screen just in case you fly through it, okay? But go ahead and get started.
I got Ken Roberts. Oh, I didn't look at occupation yet. Sorry. That's what I have. I only just got the funny count.
Speaker underscore occupations.
Oh, it's probably. Yes. That's what I was.
Yeah.
Cool. Okay. So I just need to rehab it.
All right, I'm sure there's some folks who would like more time, but we're going to go ahead and go through this. The clock is ticking down, so there's no way around it. All right, so this, as I mentioned, is a multi-step process. So I'll kind of walk you through the steps as I thought of them, and we'll talk about it as we go. So for me, step one is to count the number of funny ratings. So I assume you thought about, well, I've got this ratings column. It's got this funny rating in there, and one thing to check. So if you look at ratings list and check out the head, I hope you looked past the very first dictionary and didn't just assume that funny was always the first dictionary in the list, because it's not always the first dictionary. So I hope you didn't assume it and you actually looked for it, because sometimes it's not the first. And then one question you might have before you write a function to do this is, oh, I wonder if funny is always there, which is a good thing to check. And to me, the fastest way to check that is actually just to use a string contains method. So I'm actually going to look at ratings, which is a string, not ratings list, which is a series of lists, and do a stir contains funny. And then, I mean, this outputs, trues and falses. But if we do a value counts, what we're looking for is, are there any falses? So this would seem to indicate that funny is always going to be in our dictionary. If it wasn't, then we might need to account for that. Like, we don't know if something has 0 funny ratings, does it say funny 0 or does it not exist? And that's what you're looking for. And so I would sense that it does exist, so we don't have to check for that condition. Okay? So here's the function I wrote, which now I realize you could definitely do in a comprehension form, but I'm going to write it in the form I like, which is like this. So I'll just go ahead and write the whole thing out for time's sake. List of dicts. And so what you're doing is you're just iterating for D in list of dicts. Whoops, forgot my underscores again. List of dicts. If if the name is equal to funny, then we will return that count. Okay. So this is, I think, if I wrote all that right, I think this is the function I used to get that data out of there. And let's go ahead and apply it and see how the results look. So ted.ratings list.apply get funny ratings. And I mean, this looks like reasonable results. We recognize that 19645 number. So these, I think this looks good, and you could do some checks to make sure. But I'm just going to go ahead for time's sake and just go ahead and save this as our funny ratings column. So TED bracket. One more time. Right, and that is what I want because so he's saying I'm not accumulating, I'm just returning the counts. And I'm not trying, so these, just to be clear, these are the rows in the data frame. So this is talk number 0, how many funny votes did it have? I don't want to add these numbers together because these are the counts for each of the individual talks. Does that make sense? Okay. So I called this TED.funny ratings. Okay. And TED.funny ratings. Make sure that looks right. Again. Okay. And seems fine. All right. So that's probably like the least interesting part of this. The question is now, what do I do with this? And the first thought that came to mind is, and I hinted at this when I said you should save the column, the num ratings column from the previous exercise, which is I thought, well, let's calculate the percentage of ratings that are funny. So 19,645 out of how many were funny, and that would be some measure of how funny was this talk. So TED bracket funny rate is what I called it. And TED.funny ratings divided by TED.num ratings. Okay? And now we've got this measure of how funny is a talk. How might we spot check that this calculation makes sense? How might we just do kind of a gut check? Anyone have an idea? One more time? Well, yes, more than just that it produced a number that's in the range we expect, but that this is an actual useful measure. Maybe this question's a little too vague, but anyone have any ideas? So here's what I'm going after, and I think my question's just too vague to really get at what I'm saying, is so I might say, let's go ahead and sort by these values. Let's look at what talks have the highest funny rate and look at the occupations and see if it kind of matches up with our human intuition, okay? Because if it doesn't, then maybe we did something wrong up to here, okay? So if we sort by funny rate and then check the speaker occupation, okay? You will get, this doesn't tell you anything, because we need to take the tail, because that is where we have, actually let's do even more, let's do 20. So we sorted by funny rate. Funny rate is, the sorting is ascending order, thus the highest funny rates are at the bottom, thus these are the speaker occupations of the 20 funniest talks as judged by funny rate. And this kind of matches our intuition that comedians and a lot of comedians, satirists, actors, data scientists, jugglers are funny. And like this makes sense. So even though this doesn't prove that we did a useful calculation, it indicates that we probably did something useful because people whose job it is to be funny are getting people are clicking funny on the rating box, okay? And then similarly, and we're not giving any of these folks a hard time, but these are the 20 least funny occupations: penguin expert, spinal cord researcher, thinker, educator, AIDS fighter. I mean, I'm sure these are great talks. They just weren't marked as funny. So this kind of all makes sense. People aren't marking funny on these talks, okay? So that's step 2. I can't remember if I wrote that, but I intended to say that was step 2, and here is what I'd call step 3, which is analyze the funny rate by occupation. And you might already be thinking, there's a caveat here we need to be aware of, but I will get to that. So if I want to calculate the mean funny rate per occupation, what structure would I use? What's the thing I'm using to do that? Yes, but like what's well, not weighted, but we'll get back to that. But what's the code I'm using here? A group by, yes, sorry, that's what I meant. So we're using a group by because I want, again, for a group by, you're thinking for each something, I want to take some aggregation function of some other column. So for each occupation, I want to take the mean funny rate. And that's how I translate group bys into code. So group by for each speaker occupation, what is the dot funny rate dot mean, okay?
Calculating the average of the averages. I think you'd be better off calculating the sum of the funny ratings over the sum of the ratings.
Oh, okay, I like that. I'm not going to do that in that way. I'm going to do it in a different way, but I appreciate the point. He's getting at, well, the sample size problem is the sample size, but rather, well, I don't know how to explain it quickly. You made a great point. I just don't know how to explain it quickly. So let's go ahead and sort this. And so these are by occupation, but as these are the mean funny rates by occupation. And the highest values, comedian, writer, juggler, actor, etc. The problem with this calculation, as the solution this gentleman mentioned would solve, is that a lot of these occupations have a very small sample size. And one way we could see that is by changing the mean to an ag and saying count and mean. But the other way you can just see this is just in general, if you do speaker occupation.describe, you'll just see that if you didn't know, you can do describe on non-numeric columns. They do a count of non-null values, how many unique values, what's the top value, and then what's the frequency of that top value. So out of all of these 2,544 non-null instances, 1,458 of them were unique, meaning there's only one instance of that occupation. So that tells us already with a weakness that is a weakness of our approach, in that we have this very small sample size on a lot of things. So my next step, and again, there are other ways you could do this, but this is how I think this is one of the more interesting ways, is step 4. We're going to focus on occupations that are well represented in the data. And this may not be quite the most efficient way to do things, and in fact, there's some ways that would be a little less code, but I think you'll get something useful out of this particular approach. And what I want to do is look at speaker occupation.value counts. Okay, and here are my value counts. We've got a writer. There are 45 of them. And then down at the bottom, there are poet of code. I like that. There are all these ones, okay, because there's a lot of occupations that only appear once. So what I want to do is I want to generate a list of all of the occupations that are somewhat frequent, okay? So one question is, what is the data type of the value counts output? What are we looking at? It is a pandas series, okay? So many pandas operations output a data frame or series, and because of that, you can manipulate the output of a lot of functions like any other like any other series or data frame. And what I'm talking about here is I'm actually going to save this as something called occupation counts, and this is indeed a pandas series. And I can filter that like any other series. Occupation counts, bracket, occupation counts is greater than or equal to 5. Okay? So I've now filtered out only include occupations that appear at least 5 times. Now, I filtered a series, so occupation counts as a series. I have filtered the series by their values. Then I'm going to take the index, okay? And I'm sorry, it doesn't look great on screen because of the font size. But we're going to save that as something called top occupations, okay? So top occupations is actually, I believe it's a NumPy array, top occupations. Oh, it's an index, so it still remains an index, but an index can be treated like a list, okay? So you can think of this as just a list of the occupations that appear at least 5 times. So rather than doing a weighted average, which is what I think 2 folks were suggesting, I'm actually going to use all the data, but I'm just going to cut it off at an arbitrary value and say, let's only include occupations that appear at least 5 times in the data. So what I need to do is to filter it down. And there's a lot of ways you could do this, but here is the kind of slickest way to do it, is we want to filter the data frame to only include talks by occupations with at least 5 instances. So I'm actually going to just say ted.speakeroccupation.isIn top occupations, okay? Now, that pulls out, outputs a data frame. So the way isIn works, it's kind of in the name. So it's checking for the existence of top occupations. It's like a bunch of ors. It's like saying, you know, if you ever do multiple conditions to filter, you say something equals something, or something equals something, or something equals something. As an alternative, you do dot isIn, and then you pass it a list or something list-like, and it will check for whether it's a member of that list. Hope that was kind of clear. But I'm going to save this, and I know this is a lot of intermediate objects, and I hope the names are good. But TED top occupations is my intermediate data frame that only includes talks by occupations that are represented at least 5 times. And this still includes 786 talks, which is not a huge, sorry, it's not, I mean, we've lost 2/3 or 3/4 of the talks, but we still have a lot of data to work from. So what I'm really doing is I'm just going to redo my group by and see, okay, now that we've eliminated all the talks, all the funny, essentially we want to get at the funny rate, but only when we have at least 5 data points. So we're going to TED top occupations.group by, speaker occupation dot funny rate dot mean, and it still goes on dot sort values. Okay, so I know that was really long, and you may have gotten lost in there. My apologies, but basically we've just eliminated all the small sample sizes, and we end up with a list that looks similar to our previous list. So these are the least funny occupations that have at least 5 data points. Okay, so you know, here's the, if you will, the bottom of the list. Here's the top of the list, and you know, it kind of still makes sense. What are the, so I've mentioned one weakness of this approach, which is, you know, 5 is still a pretty small sample size. It's not a great sample size. What are some other weaknesses of this approach?
Well, I was wondering how many people could actually be a global health expert,
Right.
data visionary, or performance poet and multimedia artist.
Right.
It turns out that in those categories, all of the talks are by the same individual.
Right. So that's a big weakness of the approach in that we apparently have a performance poet, comma, multimedia artist who has done at least 5 TED Talks, but it happens to be all the same person, and that person is funny. So it doesn't really tell us that performance poets and multimedia artists are funny, maybe when combined, but that particular person is funny. So that's a big weakness of the approach. What's another weakness? Is that, yeah.
Yes, sometimes the speaker occupations, what will be in the raw data, distinct values actually have some overlap. Like you might have comedian,
Right.
and another one is poet and comedian.
Right. So ideally, we would want to look at like data visionaries separate from global health experts. So you could split this, and then how do you decide? Do you assign them the first occupation? Do you double count them? But the point is, when people have multiple occupations listed, how do you deal with that data? And we haven't really dealt with it. We've just left it as is, which is another weakness of the approach. Okay, well, I know we're at time. I'm going to do 2 things. One is I'm going to go through the kind of the lessons to take away from this exercise, and the second is just to wrap up this overall tutorial. But any questions about this exercise before I get to that? Okay. So the lessons to take away, and I'll try to be brief. I don't want to keep you too long. So number 1, check your assumptions about your data. Did you assume funny was always in those dictionaries? Did you assume that funny was always the first element? Those kind of things. Number 2, check for reasonable results. And that's when we do our funny rate calculation and we check, does it make sense? Like, does it match with our human intuition? Number 3, take advantage of the fact that pandas operations often output a data frame or series. And because of that, you can do a lot of chaining. You can manipulate the output a lot of times. That's kind of an underappreciated feature of pandas, in my opinion, is you can do a lot of manipulation on the output and not just the input. Number 4, watch out for small sample sizes, as we've talked about numerous times. Number 5, consider the impact of missing data. And so pandas generally ignores missing values by default. Thus, most calculations won't fail due to missing values. So you need to be very we didn't hit much on missing values in this tutorial, but you have to be cognizant of missing values because it does not generally cause pandas to throw up errors. You need to be aware that it's doing calculations on the non-missing data. And lesson number 6, data scientists are, of course, hilarious. The data proves it. They were the top 5 in terms of occupation. They were number 5 in the list. So tell your friends that you are hilarious. Okay, so that's it. Just to kind of conclude some housekeeping. Number 1, let me go to the very top of this notebook and show you the survey link. So if you've already closed your notebook, it's bit.ly/PyCon 2019 survey, another sweet bit.ly link I snagged, PyCon 2019 survey. I'd really appreciate it if you would fill it out. I assume they look into it when deciding who to bring back next year, and I'd love to come back. So please do fill out that survey, and I would love that. I'll be posting all the code from today, or most of it, with a lot of comments on GitHub. You'll receive an email once I have done that. It'll be perhaps a couple days. If you want to keep in touch, I've got a website. It's Data School. I've got an email newsletter. You can keep up to date with any of the videos I release or my courses. I have an existing course on machine learning. I have a Pandas course on Data Camp. I'm working on some courses about Conda and about the Jupyter Notebook. So if you want to hear that, please sign up for the email list. If you like the logo, I've got some Data School stickers and magnets and buttons up front. Feel free to grab me in the hallway later if you want to talk pandas or data science. I might be organizing an open space around pandas, so watch for that. If you want to come chat more about pandas or ask questions, I'm happy to do that. And that is it. Thank you so much for joining me today. This was awesome. Really appreciate it.